Welcome everyone to this week's Science News. Today we'll talk about quantum computers that are really good at guessing, room temperature superconductors again, how we changed the tilt of Earth's axis without noticing, the environmental impact of a metaverse, a computer chip that mimics the human eye, whether smart drugs actually make you smart, how carbon dioxide emissions look like, flying taxis, an announcement of an announcement, and of course, the telephone ring. Physicists from the University of Southern California have demonstrated for the first time that quantum computers don't slow down as much as conventional computers when problems get more difficult. You might think this was a convoluted German way of saying they've shown that quantum computers are faster than conventional computers, but that's not what they showed. That quantum computers can solve certain problems faster than conventional computers has been shown previously. It's called quantum advantage and was demonstrated for the first time in 2019 by Google. We just talked about another such demonstration from IBM last week. In the new study, the quantum computer was actually slower than a conventional computer, but when they made the problem more difficult, then the quantum computer didn't slow down as much as the conventional computer. To give you an everyday example, people have two ways of dealing with books. Some put them in the first place that comes to mind. Others carefully sort their books. The first method is faster if you have few books. But the more books you have, the more time you'll save with the second method. It scales better. The same is the case for algorithmic solutions of certain computational problems. Quantum computers scale better when the complexity of the problem increases. For this new study, they used a 27-qubit quantum computer from IBM and looked at what's called the bit string guessing game. For this, you create a random bit string and then the algorithm has to guess it by asking as few questions as possible. A conventional computer needs a large number of guesses. Indeed, the number increases exponentially with the length of the string. A quantum computer now can solve this problem correctly with only one guess. You do this by creating an initial state that contains all possible answers, and then you compare the answers to the bit string, but without looking at it, so it doesn't count as a question. You switch around all those superpositions, again without looking at it. When you eventually look at it, the quantum computer is in the same state as the string you want to know. It's magic, basically, just that we call it physics. In this figure, TTS means time to solution, and it's shown as a function of the number of bits you're guessing. The diagonal thin white lines show the scaling of the conventional non-quantum solution. The dashed lines down here show the scaling of the pure quantum solution. As you can see, they find that the various methods they tried all scale better than the conventional algorithm for a small number of bits. As the number approaches the number of qubits, that becomes more difficult, but it's probably due to noise. I guess I'm easily amused, but I find this much more impressive than quantum advantage. Maybe one day I can get a quantum computer to find my GR textbook. Remember the supposed superconductor breakthrough that made headlines 2 months ago? A group of scientists from the University of Illinois, Chicago now says they can partly reproduce the finding. Here's a quick summary of what happened. In March, Ranga Diaz and his team at the University of Rochester announced in a Nature paper that they'd made a breakthrough in developing a high-temperature superconductor. They had produced a compound, which they said is lutetium hydride, compressed it between two diamonds at 10 kilobars of pressure, and watched it change color. They say that, along with the change in color, the electric resistance changed and the material became superconductive, and all at room temperature. If what they said was true, that'd be a really big deal. 10 kilobars of pressure is still a lot, but it would be a big step closer to room temperature superconductivity, which could make the electric grid dramatically more efficient. However, in the next 2 months, several groups in China tried to reproduce Diaz's findings and failed. They say they made the same compound and found it to look similar. It also had the color change, but it wasn't superconductive. The authors of the new paper now say that they obtained a sample of the material from the Diaz group and did their own tests on it. and they report that they did find a sharp drop in electric resistivity that is compatible with the claim of superconductivity. They also speculate that the reason why the Chinese groups did not see the same might have to do with the sample preparation. This article is not yet peer-reviewed, so enjoy this with a bit of caution. I'm sure this isn't the end of the story, so stay tuned. Hello? Rishi. They did what? Use a shopping cart handle to look for heart arrhythmias? Is the butter price that bad now? Right, who needs a cardiologist if they can go to Tesco instead? Yes, I'd say that using a device that can barely roll on four wheels for a medical exam is a really good idea. Happy to help. According to a new study by an international team of geophysicists, not only can we move mountains, we can move the entire planet. They found that human activity has shifted the tilt of our planet by nearly 80 centimeters. How? By pumping massive amounts of water out of the ground. They figured this out by carefully tracking the spots that our planet revolves around, which, you'll be surprised to hear, is not the location of certain members of the royal family, but rather two places on the north and south ends of our planet called the rotational poles. The rotational poles slowly drift. Records of this drift go back over 100 years, but they've become increasingly more precise since we have satellite data. Over the past 100 years, the Earth's rotational pole has slowly but consistently moved slightly westward along this green line every year, until 3 decades ago, when that drift began to slow and head eastward, ending up along the red line called OBS. Previous research had looked at the effect of shifting ice sheets and glaciers, but that didn't entirely explain it. According to the new study now, the reason for the motion of the rotational pole is that we pump massive amounts of water out of the ground, and most of that ends up in the oceans. They calculated that in the period between 1993 and 2010, we have redistributed more than 2,000 gigatons of groundwater, which shifted Earth's poles on average 4.36 centimeters eastward per year. The researchers are now investigating whether the eastward drift of the rotational pole is also the reason for the steady expansion of the sushi section in your supermarket. Researchers at Cornell University say that the metaverse might be helpful to the environment. The metaverse is Mark Zuckerberg's vision for the future of humanity. Soon, he thinks, we'll all live in a partly virtual space and will never have to leave the house again. For this new study, the authors extrapolate both the increase of energy consumption from computational demands of the metaverse, as well as the energy savings that come primarily from moving around less. They looked at 5 sectors: work, education, travel, NFTs, and gaming under 3 different scenarios for how widely and quickly the metaverse will become commonplace. The projections found that energy could be saved by 90% of the world's population when shifting to a metaverse lifestyle. Residential energy consumption would increase, but the energy saved would outweigh the energy used in 4 out of 5 categories. Gaming is the only category in which additional energy would be expended. They also calculated how much carbon dioxide emissions would be saved by this. If 90% of the world population shifts to a metaverse lifestyle, I guess we better get used to eating virtual bananas. A group of researchers from Melbourne has developed a microchip that could become a computer eye. It's modeled after the human visual system and can capture, process, and temporarily store visual information. The device is a thin layer of doped indium oxide, just about 3 nanometers thick and sandwiched between 2 electrodes. It's light sensitive and can change its conductance based on the intensity and duration of the light signals it receives. This is similar to how synapses in the human brain can change their strength based on the activity of neurons. Such computing chips are called neuromorphic. The researchers then combined many of those responsive sensors in layers, like one does in a neural network, but in this case it's a hardware network, not a software network. The neuromorphic eye works without additional external parts, and it retains information reliably for longer than previous devices, up to 10 minutes. In the proof of concept experiment, the team found that the device was able to detect and analyze UV light in real time. The researchers hope that the technology can be further developed and be used in autonomous machines and potentially even aid in the development of bionic eyes. Maybe these smart chips could also help me find an answer that has eluded me for years. When my eye doctor asks, "What's better, 1 or 2?" is the answer 1 or 2? A new paper by researchers from the UK has found that so-called smart drugs, such as Ritalin or Adderall, don't actually work as cognitive boosters. These drugs are common prescription medication for people with ADHD and some other conditions, but are also popped by biohackers who hope to boost their brain performance. The team conducted 4 double-blind randomized tests with 40 healthy participants. The participants were given either placebo or one of 3 popular smart drugs. They then had to solve what's known as the knapsack optimization problem. Participants were given a virtual backpack and a group of items with varying weights and values. The task is to choose the items with the highest value given a certain maximum weight. The researchers found that while smart drugs increased the motivation of participants to continue with the task, leading to more time spent and more moves made, that didn't improve the result. The team hopes that the study will lead to future research on genuine smart drugs and potentially the dissuasion of non-prescription medication being used for potential cognitive boosts. In dumb drug news, the study to test marijuana users' ability to eat a whole pizza in one setting is set to begin next month. This next bit of news is less about science and more about a science visualization. NASA has come out with some amazing clips that show us what we'd see if carbon dioxide was visible. First, we'll take a look at the carbon dioxide released over the Americas in 2021. Carbon dioxide from fossil fuels is colored orange. Carbon dioxide from burning biomass is red. Carbon dioxide from land ecosystems is green, and carbon dioxide released from the ocean is blue. And those green blinking lights across both continents are plants that absorb carbon dioxide during the day and release it at night. You can see that a lot of the carbon dioxide is released over North America, and that wildfires contribute as temperatures rise during the summer. This is Asia and Australia. First thing you see is that Australia releases far less carbon dioxide than China and India, in part because the latter 2 countries are currently industrializing, and also because, well, nobody lives in Australia. That dark patch in the northwest is also interesting. Though it's part of China, that area is the Tibetan Plateau and very sparsely populated. Finally, we're on to Europe, the Middle East and Africa. See that northern half of Africa that doesn't flash as much as the southern parts? That's the Sahara Desert. Not many plants there. Most of the carbon dioxide in this part of the world comes from Europe and parts of the Middle East, though Africa adds a lot of emissions when farmers burn crop residue to clear their land. These visualizations are part of a recent push to better understand where carbon emissions come from. NASA has the Orbiting Carbon Observatory performing the task since 2014, and ESA plans to launch the Copernicus carbon dioxide monitoring mission in 2026. Ambitions always fly high at the Olympics, but it looks like at next year's Paris Olympics, visitors might be flying high too, at least when they can afford it. The city of Paris wants to become the first ever site for flying taxi service and hopes to get a small fleet up and running before the games are underway. The fleet of flying taxis, if approved by European regulators, would be made up of electrical vertical takeoff and landing vehicles, or eVTOLs for short. eVTOLs use multiple small rotors instead of the single large one found on helicopters. They've been heralded as the next big thing in urban transit for years now, but this is the closest we've come to our flying taxi future. While flitting over Paris's traffic jams and crowded train stations might sound nice, services will start small and exclusive. Flights will only run on a few selected routes, and because the batteries must be recharged frequently, they'll be short. And while prices have not leaked out, it'll probably cost slightly more than an Uber ride. But it'll all be worth it, if only because it'll finally make sense of the phrase, getting a lift. And finally, I want to announce an announcement that'll come tomorrow, June 29th, from several collaborations that have been using pulsars to look for gravitational waves. A pulsar is a highly magnetized rotating neutron star that emits beams of electromagnetic radiation. For some pulsars, this beam periodically points into our direction. It's an extremely accurate signal. If you watch a collection of pulsars, you can use their signals to look for distortions in the travel time that would come from a bending and stretching of space. This pulsar method can detect gravitational waves at much longer wavelength than Earth-based gravitational wave interferometers like LIGO. Gravitational waves with such long wavelength could, for example, come from supermassive black hole mergers. There's probably an embargoed paper making the rounds at the moment, but I haven't seen it, so I can't be accused of spilling the beans. All I just said is pure guesswork. Tomorrow we'll know more. Mr. William from Ockham, the one with the razor. What an honor. Oh yes, I saw this. First time I've ever seen a press release from a philosophy department. I hope we'll see more of this. Imagine the headlines. Breaking! Philosopher discovers new way to question the obvious. Or maybe, philosopher proves that universe does not exist. Students request refunds. Sure thing. We've never had more hypotheses to shave than today. Thanks for calling in. I go on like this, they'll hire me at The Onion. I probably have accounts for hundreds of websites, stores and services. I bet you have too. And if you're anything like me, you fill in your personal details very creatively. But of course, this isn't always possible. If you want the carpet to be delivered to your door, you have to actually give them your address, right? Unfortunately, a lot of companies then go and sell off user information for money to data brokers, which is the reason you're getting all those phony phone calls. Most countries have laws against that, and you can ask for your data to be removed, but doing this takes up a lot of time. Luckily, there's now an easy way to automate this process, Incogni, who have been sponsoring this video. Incogni automates the process of getting you out of those databases. You sign up and they'll contact the big sinners, request that your personal details be removed, and they'll keep on doing that. I'm super paranoid about my privacy after a collection company came after me a few years ago, threatening to sue me for not paying for something I didn't buy in the first place. Extremely unpleasant experience. So I'm glad there's now a simple solution to unfriendly people doing nasty things with my personal details. Incogni is super easy to use. You sign up, give them the information they should look for, and they go to work, like basically within a minute. It's a simple way to put your mind at rest, and I can even help you save some money along the way. If you use our code Sabine or the custom link in the info below, you'll get 60% off the annual Incogni plan, which isn't expensive in the first place. So go and check this out. Thanks for watching. See you next week.